Question number 3. The zeros of a parabola are -3 and 5. The parabola crosses the y-axis at -75. What is the equation of the quadratic relation in factored form, and what are the coordinates of the vertex? Okay, so the zeros have been given to us, and the y-intercept has been given to us. It's at -75, so that would be the point 0 with -75. We also know that factored form looks like this: y equals a x minus r times x minus s, where r and s are the zeros. So I'm going to plug those zeros into this formula to see what's next. So I plugged in the two zeros, -3 and 5, so it's x minus -3 and x minus 5. So these two minuses will become a plus. So then I get the equation y equals a x plus 3 times x minus 5. Notice that I still have not solved for a. I have used this piece of information and this piece of information, but I have not yet used this one, so I need to use the y-intercept to help me find a. So I'm going to plug in 0 for x and -75 for y, and then solve for a. I plugged in 75 for y over here, and then I plugged in 0 for x over here and here. I solve for that and I get a equals 5. So now I can write the equation. If I go 4 in from either side, then I end up with the axis of symmetry at x equals 1. To determine the y-coordinate on this axis of symmetry, I need to now take this value of x equals 1, and put it into my equation. I substitute x equals 1 into the equation here that we determined before. So I get 1 plus 3, 1 minus 5. 5 times 4 times -4, so y equals -80. Therefore, the vertex is on the axis of symmetry at -80. For the relation 3 times x plus 1 times x minus 3, state the zeros or x-intercepts, state the equation of the axis of symmetry, and the coordinates of the vertex. This is already in factored form, which gives us the x-intercepts. So we can write those down. Factored form is a times x minus r times x minus s, where r and s are the x-intercepts. Therefore, the x-intercepts are -1 and 3. We want the equation of the axis of symmetry. I've plotted the two zeros on the x-axis. That's why they're called x-intercepts or zeros. The equation of the axis of symmetry would be halfway between those. The distance between these two is 4, so to go halfway, I'd have to go 2 in from here or 2 in from here. Therefore, the axis of symmetry will be this red line, halfway between -1 and 3. I go 2 in to get to +1, or go 2 back to get to +1. The axis of symmetry is x equals 1. The coordinates of the vertex, well, the vertex is going to lie on the axis of symmetry. It cuts the parabola in half. So we want to find the point down here where it meets the vertex. So this value of x can just be plugged into the y function in order to figure out the y value for the vertex. I plugged x equals 1 into the formula for y to find the value of y at the vertex. So I put x equals 1 into y. Here it is here. Solved it, gets y equals -12. Therefore, the vertex is 1 with -12. Determine the equation of a parabola in factored form that has zeros 3 and 7 and an optimal value of 6. So that would be your maximum or your minimum. So I'm going to figure out what factored form is, how does zeros fit in, and then how does the maximum fit in as well, or minimum. We know that factored form is y equals x minus r and x minus s. So x minus the first 0, x minus the second 0. So I'm going to write that in a moment, and we'll still have a defined. I have used my 0 information over here, the 3 and the 7, in my equation. I still need to find a, and I need to use the maximum or minimum to find a. If the optimal value of the parabola is 6, that means this is a y value of the vertex. So if I can find the x value of the vertex, then that will help me out. I've done a little sketch over here with the zeros of 3 and 7, and my maximum value is going to be 6. So it's going to be up here somewhere, actually, on the axis of symmetry. But what is the axis of symmetry? The whole distance is 4, so if I go in 2 from either side, I will get to the axis of symmetry, which makes it x equals 2 from one side, 5. So if x equals 5 at the vertex and y equals 6, I better not do that. The vertex then is 5 with 6. I'm going to use this point now in our equation to help isolate a. Putting the 5 and the 6 in from the vertex into our equation that we have in factored form, I end up solving to get a equals -3/2. Now I'm going to write the equation. I took the equation from up here that has the zeros in it. I figured out what a is. There's a equals -3/2, and now I've rewritten the equation. -3/2 times x minus 3 times x minus 7.